Now we turn to a new idea. Every data structure has two views. One is the logical view, and the other is the physical view. Next, we see how the clean picture in our head can differ from where the bytes really sit in memory. Every data structure has two views. The first is the logical view. This is the clean picture. It shows what the structure means. The first node holds 10. An arrow leads from the first node to the second, which holds 20. A second arrow leads to the third node, which holds 30. After 30, the chain ends. It points at null, which just means nothing more comes after. So the logical view is a clean chain, 10, 20, 30. Next, let's see where those bytes really live. Now the physical view. This is where the bytes really live in memory. Each field sits at its own address. The same three values now look very different. Let's follow the chain in real memory. Node 10 lives low down. Its next field does not hold 20. It holds an address. The address 7000. That is where node 20 lives. We follow that address and we land here at node 20. Its data field holds the value 20. Notice this row sits far away from node 10. The two nodes are not neighbors in memory. Node 20 also has a next field. It holds the address 6000. That is the address of the third node. We follow that last address and we reach node 30. Its data field holds 30. Its next field holds null, which means the chain ends here. There is no fourth node. So the logical chain 10, 20, 30 is neat and in a line. But in memory, the three nodes are scattered and pointers join them. Same data, two pictures. In C, we must always track both. In the drawing, 10 and 20 sit next to each other. So do they sit next to each other in memory? Sometimes yes. Look at the left side. This layout is contiguous. 10, 20, and 30 sit at neighboring addresses, 1000, 1004, 1008. The addresses go up by 4 each time. Here the order really is the position. Now look at the right side. This layout is linked and the story changes. 10 lives at the address 3000. 20 lives far away at the address 5000. The values are scattered across memory. The arrows, not the positions, carry the order. So this is the lesson. Nearness on the page is not a promise about addresses. The drawing spaces items out to show order, not location. Before you do address arithmetic, check that the layout is contiguous. For a linked layout, follow the stored next address instead. Never just assume that neighbors on the page are neighbors in memory.